All right, so I did it again. The first part of the problem I didn't record, but I do think it'd probably be good if I record the second part, because there might be people who want to review this, because what we're going to do here is a little challenging, I think. I have to throw away that information, because that's no longer valid or relevant, because it doesn't take 7 seconds for the sound for the rock to fall. It takes less than 7 seconds for the rock to fall and hit the water, because there's some time for the sound to come back to me at the top of the bridge. I don't know how long that is. So I have to subtract a little bit from the 7 to indicate that the time that the rock is falling is slightly less than 7 seconds. All good? What am I going to do? How am I going to figure that out now? Because I just took away one of the things that I knew about the problem. Right? I knew the time, and now I don't. Yes, ma'am?
Well, we figured out the displacement before, right? So I know it to use that.
We can't use that because that displacement was based on it traveling the full 7 seconds to reach the water, and it traveled less than 7. So we know the bridge is a little shorter than 245 meters. We just don't know by how much. But we do know that the speed of sound travels at 340 meters per second. So we know that whatever the height of the bridge is, the sound is going to have to take t amount of seconds to go from the water line back to the top. Now, there's no acceleration here because sound travels at a constant speed through the air. And I know how fast it travels. So what I'm going to do is I'm going to remember that this is the distance that the sound has to travel to get back to my ears. It's a displacement. This is the time that the sound takes to travel to me. And I created a relationship that has two unknowns in it. But I also remember what I did in the easy part of this problem. And that was to take the information that was presented to me and use it to relate the displacement to how long it took the rock to fall. I just have to make sure I take away the amount of time that it takes the sound to come back. Now, what I've done here, if I get rid of that, is I've created two equations with two unknowns. Right? A system of equations. It's not a system of linear equations, by the way. It's one linear and one quadratic, but it is a system of equations. I could use algebra to figure out the value for t. And subsequently then figure out delta x. I think it's easier to eliminate delta x than it is to eliminate t, which is why I'm saying it that way. So if it were me and I was trying to solve this problem, I would probably just put this in for delta x and do the quadratic to get t. What do y'all think? That takes a level 1 problem to a level 3 problem, doesn't it? So yeah, some of these problems are going to be hard because some of you are capable. Now, some of you are less capable. This is not a test question. It's a fun question, though. It makes you think about it. And our goal is to be thoughtful. So if you get a homework question that's like this, that you think maybe there's a trick to it, it's not a trick. Be thoughtful. I'm not saying you'll get it. But I need to have homework questions that are accessible and homework questions that challenge a little and homework questions that challenge a lot. I would argue this one probably challenges a lot because it's the first time you've seen something like this. Did I introduce anything here that you were unfamiliar with? But it's probably being referenced in a way you've never seen before. I'll accept that part. So we'll look for this in the future, right? A way of thinking outside the box. I'm still staying inside all the reference areas that we discussed. I'm using a model based on the motion of the object. I'm using that model to help me figure out a relationship that I might use the information given, and then add that wrinkle. So I can do the arithmetic, but that's probably the least interesting part here. Do you want me to continue? I will, or I can move on to a different question. Yes, ma'am. Yeah, that's what I'm asking. I'm going to do the substitution then. That's going to put 340t equals 5 times 7 minus t squared. There's no straightforward way to do this, so I'm going to go ahead and do the math. I'm going to square the binomial here, and then collect it to produce a quadratic, and then probably solve for the two values for t. I'm suspecting that one of the values for t is positive and one's negative, just from experience, because I think there's only one value for t that's going to work here. But I'm going to continue the problem in that regard. I can divide 340 by 5, though, or you could. 68? Is that right? I did the binomial expansion. Are we all in agreement? Did I do my math okay? I'll move the 68 over. That's a 2. 8 minus t plus t squared. That's it. I'm at the limit. Time for us to do some stupid math. You just do the math thing. I'm not going to do this part, okay? I mean, I don't want to do the negative b plus or minus all that garbage. Can that part be you guys? Like, I'll just call on one of you to tell me the two t's to prove that you can do the quadratic formula from yesterday, because we talked about it yesterday, just to make sure that I'm doing my part as teacher and checking for your response. And then putting people on their toes who I know are really not paying attention because they're freaking hot and they're just dealing without, sweltering too much. But these kind gentlemen are fixing it for us, and it's going to be awesome. Now that we have found that t is 0.6, and like I said, you could have estimated it by just using the 245 from earlier, but you can plug it in there, find your new value for time, and get delta x. Of course, if it were me, I would plug it in there. It would be easier, and they both have to be the same delta x because we set it to be so. So 340 times 0.6 is the answer. I mean, you could put it in the motion equation, but that's going to be more work. And you are thoughtful, efficient young people. And if the old man can figure that out, the young ones can do it. All right, so I think we have talked this problem into the ground. So is there another homework assignment to which you would like me to speak? Yes, sir.
I can't tell if it's anywhere from number 7. Is that just using, a cyclist traveling at constant 10 meters per second passes another doing 5 meters per second. The second cyclist, not wanting to be beat, accelerates constantly at 1 meter per second squared until they eventually catch the first cyclist. How long do they have to maintain this acceleration? How fast are they going when they reach the first cyclist? And how far have they traveled?
I like this problem. So the first cyclist is traveling at a constant speed of 10 meters per second at time 0, right? Time 0 is the moment the two cyclists are at the same position. Is that all okay with you guys? Did everybody understand what I just said? Did everybody hear the question? Well, apparently you got to speak from the diaphragm. I'll help you out. Cyclist number 1 is traveling at 10 meters per second at a constant rate of speed. They are not accelerating. Now, I'm gonna throw this out there at this moment because I'm afraid you're not paying close enough attention. But if there's no acceleration, you make A 0 in all of these, then you get a whole new one equation, right? They all collapse. And you either get V equals V naught, which makes sense because the velocity is not changing, or you get delta x equals V times t. That's what happens, right? When all of these, when you put 0 in for A. So when he's not accelerating, it's distance equals rate times time. I know you know this because you've been to middle school and you got A's. How many of you hate the fact that I bring that up? You got A's and then I bring up stuff that you're supposed to know how to do and you can't do it. I love bringing that up. I love it. I don't know why the old man can do it all, and you guys, have to constantly be reminded. All right, so this is, that cyclist looks sick, but let's just say this is the cyclist. He starts from what speed?
5 meters.
He's going 5 meters per second. That seems to be less than the other guy. And, right, at this instant, the moment they're at the same place, he's like, no way, stand back, Satan, I got this, right? And he starts to accelerate at what rate? 1 meter per second squared. And they want to figure out how long it takes for cyclist number 2 to catch up to cyclist number 1. And then probably a whole bunch of other crap, like how far did they go? And how fast was the other guy going? I don't care. It's all one problem. Now you're probably asking yourself, this seems like a pretty straightforward question. It's not. I'd argue this is a level 2 question. I think it's right in the middle. Because once you've seen this problem once, they're all the same. Now, the smart ones out here, and there are some smart ones in the room. I can see several. Actually, I have no idea if you're smart or not. I only know the people who have been in this room before, and I already have strong opinions about some of them. So I'm going to say it this way. You could plot both of these on your TI, right? One's a straight line, one's a quadratic, and you just got to find out where they cross. You guys are smart. You play with those calculators all the time. Haven't you been to ticalc.org yet? Oh my word, there's like 100 million programs for your TI calculator. Like Mario Brothers and Joust and this other game that I'm not supposed to talk about because it's bad. And programs to do chemistry and physics. They even have it sorted by class. Can't believe you haven't been there. What do you think that port on the back is for? Charging? No. It's for putting games and stuff on your calculator. Used to be all the rage before there were phones. So you could use your calculator for that. But I'm not going to. I'm going to do it the physics way. Oh, yes.
Thank you for that. What website, please?
ticalc.org. Not com. I don't know what you'll get. And don't go to any of these websites I'd ever tell you. Don't go to any website I ever tell you. I'm recording this. I want to make sure the parents at home know I'm not telling you to go to websites and get games for your calculator. And if you ever watch any of my videos, it's already bad. So just don't watch them. I say that in the middle of every one of my videos to make sure that whatever stupid, weird thing YouTube is doing, it doesn't put me in any search engine. I don't want to be found. They're bad. Although I've said this before, in my head I sound like a rock star. But I've listened to these videos. I do not. I sound terrible. But at least in my head I think I sound fantastic. And that's all that really matters, right? So cyclist number 1, there's only one piece of information. I have their velocity. But cyclist number 2, they've given me a plethora of information. They've given me their speed and their acceleration. It's a lot. So in fact, I'm going to write out all that stuff. Delta X, V naught, V, A, T. There it is. All those things. And it starts from 5 meters per second with an acceleration of 1 meter per second squared, and that's it. So that doesn't seem like enough. I'm going to make this direction positive because I'm going to try and be consistent in all the problems that I do by making sure I make it clear to you guys that I'm choosing a direction to call positive and that I'm going to assign positivity and negativity to all of the numbers in here because that's the right way to do it. Cyclist 1, I can create a relationship for cyclist 1. And I can create a relationship for cyclist 2 based on the same things. Meaning, I know the acceleration for cyclist 2. I know the initial velocity for cyclist 2. And if I'm careful about the way I think about this, I know that at some time in the future, they're going to be at the same place at the same time. Right? I want to find out what time or what place this occurs. Because just for poops and giggles, if we were to plot this in a hastily drawn position versus time graph, cyclist 1, cyclist 2. there will be a point here where they will be at the same place at the same time. In fact, what I see here is just like in the last problem, which is now means you've seen this twice, the same exact kind of thing. I used all the information that was given to me to create two relationships with similar unknowns. I didn't use this because the final velocity for this cyclist, cyclist 2, will not be the same as the final velocity for the first cyclist. So they don't have a common variable there. So I stayed away from any equation that had final velocity in it, which leaves only one equation. I put that one together because I knew it would have time and displacement in it. Now, we just did this exact same problem a minute ago, so no, I'm not going to continue. But all I would have to do is that, right? And see previous problem for how to do the rest. Once you get that, once you know the time, you can figure out everything else. Yay, that was fun. Of course, I could argue that you made me do the same problem twice, but the sound problem was a little different. So, first cyclist isn't accelerating, right? So this is the relationship that would describe his position with respect to time. That's why I put the 10 in there. Is that the answer to your question?
No, I was saying, why did you put the 10 to the other equation? I thought that was for the first cyclist.
Yes, but they are going to reach the same displacement at the same moment in time.
Oh,
So I set them to be, in past years, I would have come up with new letters. Like I said, this is D and this is T but I don't think I need to do that with you guys. I'm going to say we can rationalize that we want the displacements and the times to be the same. We want to know when they come together again. So all the homework is easy after this, I guess, because there's no other questions, or you haven't made it to any other problems where you've had issues. So if there's no other questions, I want to talk about some new stuff. I know I only have a couple of minutes, but I use my time. Especially now that it's probably getting cooler in the back of the room. It's not getting cooler in the front of the room. But I'll point out, I had a chance to put it right there. But I am very heat tolerant, and I want you guys to pay attention. So it's in the back. We've talked about these motion problems. They're okay, they're fun-ish. You can have way complicated motion equations problems. I can add stuff. And trust me when I say you can make them complicated. But they themselves are not that interesting. If you're noticing, they are the result of just looking at comparisons between quadratic functions and linear functions. There are problems that I think mix up the genre a bit, and nobody asked about one of the ones in the homework that I know is in there that should have been asked about. And so I want to bring up a problem that is probably in your homework in some form. And it's the window problem. And then after this, I'm probably not going to talk much about kinematics problems. We're going to start talking about calculus. So that's next week's agenda for me. I want you to imagine that we're dealing with, say, a house that apparently a 5-year-old drew. And somebody's standing on top of the house. There. It's a house, right? With trees. This guy drops a rock from the top of the house. Just drops it. Okay? You are inside the house. You see the rock here and see it pass by the window and disappear here. Okay? The rock's velocity here is probably more than the velocity there. Agreed?
Yes.
It takes the rock 0.3 seconds to pass the window. It takes the rock 0.3 seconds to pass the window. How high above the window was the rock dropped? The window, you measure it to be 2 meters tall. I'll say the whole problem again so you have the dynamics of it. And there's a problem like this in your homework, I'm sure of it. But somebody stands above your house and drops a rock. You see the rock pass by the window. It takes 0.3 seconds for the rock to pass the window, but your window is 2 meters tall. How high above the window did the person drop the rock? Now, this is a problem about paying attention to which interval you're looking at. See if you can write out the information that you know about this problem. I don't have much time, so I will tell you to consider 2 separate time intervals. The interval before you see the rock and the interval while you're watching the rock. Can you write down what you know about those 2 intervals? Would you like down to be positive or negative? I'm going to keep talking. In both cases, the acceleration is 10 meters per second squared. We're dealing with a free fall problem. In the second case, we know the rock traveled 2 meters. And we know that the time was 0.3 seconds. Right? We have 3 pieces of information. We can figure something out from that. But not what was asked. In the upper interval, we don't know how long it took to reach that point of the window. We know it's accelerating at 10 meters per second squared. We only know one other thing. We know that it was dropped. So its initial velocity is 0. You know one other piece of information. Anybody here reason it out? Yes, sir.
Maybe the final velocity.
What do you mean?
So,
Yes, sir.
Final velocity was the initial velocity of the atom.
There it is. Pay attention to intervals. The final velocity here has to be the initial velocity here. That's how you connect this problem together. Once you've seen it once, connected problems like this, usually pretty straightforward to see in the future.